less than T1. For example, if T1 equal to, I say that this is 50, this is 120, this is 200. So this is set as 50 and the T2 as set as 120 and T3. T1, yeah. Yeah. If it's automatically able to identify the objects. So this is called multi-level thresholding. So first it is able to identify the black color object, then the square, and then the all three, right? First object, second object, then this one, then overlapping. Kumar, I'm not able to hear you.
Sir, you meant to say that this algorithm, which is being written on the like slide, that will be run for all the pixels that we have on the
all the pixels. That's why this is time consuming. You need a faster computer. See, for example, if is this is say 1920 HD picture, high picture, 1001, this one by 1200, correct? That means what is there? You have 0. This is first one is 0. Y is same. This will pass through for each pixel you have to do.
Okay, sir.
Using this, you will be able to identify. See, this is the reference books you can note down. If you want more detail, you can read this book. Okay. So, please note that here in this case, in the histogram method, the main thing is the distribution should be narrow and sharper. You take here that means this picture doesn't have one value of, does not have only one value. Not all the gray points are doesn't have same value. Please note that. That's why some pixels have each bar represent particular gray value. Even though the background looks single color, if you take histogram, you can say it's spread over this area, background itself. Similarly, this is the white color. This is supposed to be white paper. That also you can see the little brownish color or because of noise, all those things. So it is giving a histogram. But still you are getting a peak value, correct? It is a nice peak value giving. So you will be able to decide what is the T value you have to take, the peak value you have to take. That threshold value, you take the histogram, find the peak value, use that as a T value. If it is a single, only two objects, one threshold is sufficient, right? So then you can do. But if it is a two object, you can different. Please note that all the objects having same, this one threshold is sufficient. For example, I have a table on which I have a square object, I have a rectangular object. Color, the objects are differentiate, they are not overlapping, they are but shape is different, but same this one. So one T value. But in this case, if I have two different objects having two different colors, correct? Same color, correct? Please see that these two are same gray level. This is black, correct? This is black. This is light gray. This is dark gray. This is black, correct? There are three objects, one background, one rectangle, one square, both having same gray level. Third level is a circular object sitting on the gray object. That means what you need is two level of thresholding is sufficient. That's why here you are having two level of thresholdings. If you want more, you can set more also. Okay, but the main thing is you can see that there's a clear distribution of clear peak value. So this is called peak. This is called a valley. When you take this one histogram of any picture, This is histogram. Okay. Generally, you have Gaussian distribution many times. Nature is like that. Then if you will have peak and valley. This is called valley points. 2 valley points and 3 peaks are there. That means the image is gray values neatly spread. So easy to identify object. Okay. But take this picture. On a table, a mat is there. Correct, in your workshop. Already dirty. Correct. This is why mat. Correct. On which dirty mat on which I have a spanner. You see the almost both are same color. In grayscale, look almost same. There's not much. Now, if I take a histogram comes like, you can see that it is going like this. I have one peak value. Here I'm not able to, there's no clear peak and valleys. Then what peak value you set is going to be tough. Right? So in that case, this may be due in this, then you have to enhance the picture. Correct? Picture enhancement you are doing, that we'll see later. Correct? So in this case, it is very difficult to identify. So if there's no clear valley in the histogram, where there's no separation, like what this is called valley. Correct? This is called a valley point. It's not there. Then it is going to be difficult. Then there are several background pixels that have similar gray values. So that's why you are getting like this. Okay. Then it is very difficult to identify. In a history threshold, this is a drawback of the histogram based thresholding. Correct? Why you are doing histogram? To set what is the threshold value. Only if you know set that, then you will be able to identify the using the threshold value, you can do segmentation. Identify object is called as segmentation by applying the threshold. Okay. So histogram true threshold, one at each side of valley can be used for thresholding. Okay. Pixels above the high threshold is classified as an object. Below is called as a background. Correct. Here you have this one. So then pixel between the low and high thresholds are classified object only if they are adjacent. But we know that in this case, let me clear this. Here, these values represent not the object or the background. We have correct. So in that case, very difficult to identify object. Okay. Then what you have to do? You have to illumination, you have to change or something like that. You have to see. But in this case, difficult to identify object. Okay. So if I want to set this one, you can suppose you already know what color is the background color. Correct? The object, what you are going to take, what color or grace color already known. Then you can do prior knowledge using p-tail method. This called as p-tail method. This is name. Why they gave name, we don't know. That's how they are using. They are p-tail based this one. This method requires knowledge about the area and size of the object present in this one. Correct? Suppose this generally, please note that this one, the histogram not only for autonomous vehicle, in the factory also automatic inspection. Correct? Nowadays everything inspect automatic inspection. Correct? Using camera without human intervention. There you can put additional lights, change the background. Correct? Conveyor belt objects are coming. Correct? Conveyor belt gray color. Correct? It will become dirty. What do? You change a new conveyor or change instead of black, whether you can put a belt. So already now you know what is the color of the conveyor belt, what is the gray level. So then you can use that value as a threshold value. That is called p-tail method. Correct? That means you should know the color or grayscale value of the background. So then it will be method. Let us assume that we have a dark object, again light background. That's what I told you. My object is black color. My on which it is moving is say white color, gray color, light gray color. So my object is black color. So you will be able to easily identify. This is called as p-tail method. So for example, object occupy. Then another thing, area. Correct? This is area, frame area, in which how much area the object occupies. Correct? If it occupies more area, if you get the thresholding, correct? Your threshold, the histogram, it will look like this. More area is covered, means better this one, then you'll be able to find out. Correct? Yeah, area occupied. So percent of the area X-axis is percentage area in which my object will take, say, for example, 40% area or 50% area of the image frame. And the object has a different color than the background. Okay, this is called p-tail method. Then the next one is called mode method. If the objects are in the image have same grayscale value, the background has a different grayscale value, then image pixels are affected by zero mean Gaussian noise. Another main problem in image processing is noise. Correct? Noise can automatically improper illumination, background problem, or camera itself sometimes will add noise. If you have low resolution camera, it can add noise. Right? Some abstraction over the image or the object. That for you that you have a row on which lane marking is there. Right? So this is white color is supposed to be. Now some rainy season, what will have, some mud comes and fills slightly. What will happen? It will not look white. If more mud is there, it will become black. It will not even visible. Along with the road, everything will become black. Slight mud is there, white color is not visible. So if I take a picture, if I take a histogram, it will not look like a white. So these are called noise. Correct? Background noise. Mud or some leaves are there. Some leaves are on it. Some twigs are there. Correct? On road, anything can happen. Some paper pieces. All this thing will become a noise in the image. So because of that, that can happen. Yeah, ideal case of constant intensity where there will be two histogram. Right? Ideally, you will have clear spike. See, actually, literally, what you have to two histograms like this, having clear. But if the background, everything is having not proper differentiation, the histogram will look like this. You see, the value is not there. This is the value point. It is not there. You will get two peak value like this. Then value, nothing to worry. What you will do? This center point of the peak, you will take this one histogram value. Right? They call mode method. Okay. As I told you, where it can be used, because you know image processing is for everything, including medical image processing. Correct? For example, suppose somebody had a head injury. First thing what they do is CT scan. This is nothing but a CT scan or X-ray. Right? So take an X-ray. Then you want to see this is your brain. Correct? This is brain stem. Correct? Nose. All these things are there. Now you want to see whether there's a blood clot. For example, head injury, there's a blood clot. But by seeing this, you may not be able to see. The picture is not clear. This picture is not clear. Right? So then if I give it to histogram, you will not have clear this one to identify which is brain, where blood is there. Blood has a different histogram value, grayscale value. Correct? Blood clot. I say blood clot. Correct? This is so this is skull, bone. Correct? All these things. So histogram. Now, if the picture is like this, what you can do is you can modify or enhance. Enhancing the image first you have to do. Before doing histogram, if you are not able to get clear histogram, peak values, then best, because of an image like this, then what you have to do? You have to do image enhancement. Right? Image may be captured by camera, by character, by random variation in the intensity level, variation, illumination, poor contrast. See here, there's no contrast. Contrast means difference between the black color and white color, or between different grayscale value. That is what we call the contrast. If you increase contrast, you can clearly see it. So poor contrast is this picture. It has a lot of noise. Right? Then it has poor contrast. So how will you increase? Image enhancement you have to do. Correct? That is called a histogram modification. And Gaussian smoothing filter. There are two techniques widely used to enhance the images, any images. Many images contain unevenly distributed grayscale value. Okay? It is common to find images which are intense, all the intense value lie within a small range, such as image with poor contrast. If I take a histogram, you may get something like this, something like this, no value. Please note that this is something like this. But there are different things. brain's tissue, neurons has a different this one. You want an idea where is the blood vessels, where is the blood clotting, where is bone, where is nose. All these things have different value, but this very poor contrast image, like the CT value scan is there. But you they say that you this is what available from this. You have to identify the head injury, all these things. Then what you have to do? You have to do enhancement. You have to do. Histogram equalization is the method for stretching the contrast such images and uniform redistribution. The steps make the server selection appropriate what it is. Equations is histogram by stretching the contrast of the image. Correct? That means increasing contrast. What we do is a simple example histogram modification is image scaling. One such method, correct, is called an image scaling. The pixels in the range, correct, each pixel has a x and y value, the x comma y or this one, correct, a comma b, because it is a two-dimensional array, correct, x and y are expanded to fill a new range called z1 and zk. A comma b is the original, is this one. The formula for mapping, correct, redistributing a mapping the pixel value z in the original range into z dash value. How will you calculate this they use? Correct? Image scaling is done using this formula. Okay. Individual pixel z was increased to new value z dash. How will you do? Using this formula. Correct? Zk minus z1 divided by b minus a into z minus a plus z1. Okay. So now by doing this, you can see here this is original. This one here you can see that the histogram is only distributed this value 0 to this is 255. This is after image scaling. This is after image scaling by applying this formula. Original image, you applied this formula, then you got this image. Then if you apply, you can see that the range is increased. Separation. So I have increased my contrast. Okay. So first, that means if you poor contrast is there, you have to do image scaling to enhance the image. After that, do the histogram. Okay. If the desired gray value distribution is known priori, already know what is this one, the following method can be used. They call improved histogram modification. This is called as histogram modification technique, which is called image scaling. If you know the grayscale value, correct, distribution already you know, then you can use what you call the improved histogram, in which each pixel will go through this formula. P is the pixel, I is the individual pixel, Pi is the number of pixels at Zi level, original intensity level. Zi is the intensity level of the original histogram. Q is the number of pixels at the new level, Zi dash. See, this is Zi dash. Correct? This is. So I can do this by using this formula. I can do it. So you can see that by improved histogram modification method, the poor contrasted image is now enhanced. This is enhanced image. You can see that very clearly. You can see. Many times you cannot take again pictures with whatever available. From that you have to do. Correct. So in that case, this is the histogram for improved image. You can see that clear peaks are there. Correct. Each peak represents one. This one. This may be bone, black color. Correct. Then this is the next brain. Brain also has many areas. Top layer, bottom, deep inside. All these things are very clearly imageable. This is possible by what you call as histogram modification. After during histogram modification, then you do segmentation. Take the image, the original image, poor contrast. If contrast is there, directly apply histogram by setting the thresholding. Otherwise, do the image enhancement using histogram modification, improved histogram modification. Then this is the enhanced image. Then apply this one. Then segment. You select this value, T1, T2, T3, T4, like that you can select. The whole thing can be taken 3, 5, this can be T5, this can be T6, this can be T7. They almost all, correct? So that means up to 7 different image of parts of the brain can be seen, including skull background. Okay, so this is how you do it. Now that we are enhanced my picture, improved this and improved, then still it has noise, correct? This image may still have noise, right? Poor contrast improved, but still noise is there in the image. You have to remove. For that, there are different types of filters occur, correct? Noise filters, correct? First simplest we call linear filters. There are many different types of filter, more than 5 to 8 types, and we are going to see 1 or 2, 3 types only, correct? Simple to understanding only. Image is often corrupted by the random variation intensity value, which is called as noise. Noise is nothing but variation, unwanted intensity variation in image, in a grayscale image. Okay. So common type of noise are salt and pepper noise, impulse noise, and Gaussian noise. These are the more popularly known different type of noises in image processing. A salt and pepper noise contains random occurrence of both black and white intensity variations. See here, this is salt and pepper noise. See, this is original image, right? Without any noise. If the image is affected by salt and pepper, you can see background, no, something. Say, if you take a food, no, use go to hotel, restaurant, order some food. You wanted to add pepper and this one, you spray on it. So you see that they are all filled. So that's why we call salt and pepper noise. Correct? Next one is impulse noise. This is called as impulse noise. Right? Sudden spikes are there. You can see the white. In black, there are, you can see the white. These are called this one. Third one is Gaussian noise. Original white images now look like grays. It is a Gaussian distribution. So you can have these 3 type of noises generally, popular type. Okay. Now, how to remove this noise? You need filters. You need filter. First, simplest filter called mean filter. Correct? The mean filter is simplest filter you can use, which is also called linear smoothing filters. Mean filter also called linear smoothing filter for removing a Gaussian noise. We are going to see mean filter, correct? Median filter, and Gaussian smoothing. 3 types of filters. There are many types. More than 10 to 11 types. Don't worry. Just understanding only. Okay. So how they work, we are going to see. Mean filter. Mean filter is called a linear smoothing filter. It can remove only Gaussian noise. Correct? Easily remove Gaussian noise. This is Gaussian noise. If it has if image has salt and pepper, if you apply the mean filter, it may not remove fully. So type of noise, you have to use different type of filter. So this filter is useful for removing Gaussian noise. But it can remove other noise also, but predominantly can do this. This linear filter, which is also called mean filter, is implemented using weighted sum of the pixels in the successive window. Okay. Now, to understand this picture, you have to see. This is my frame. Right? My frame is divided into individual pixels. Each square box represents 1 pixel. This is pixel 0, 0. This is 0, 1. Each box. Okay. Now, in each box contains, I say that this is 0, 0. The value is, for example, 10. 0, 1 value equal to 15. Like that, this is the, say, 10, 10. This is the last pixel, first row, contains value equals to 12. Like this, each and everything, this value represents intensity level of that image. Because this is the image pixel value. Now, we want to, that means it has noise. How will you remove that? For that, if I want to use a mean filter, I need to use what you call as a window. 3 by 3 window. Okay. So now this is also called as a window or mask. In image processing, it is called as a mask. What this mask, what the mask, mask is a generally will be um, 3 by 3. Normally they use 3 by 3, 5 by 5, 7 by 7, 9 by 9, like odd number of things. Generally they use 3 by 3. Okay. You can use higher also. I will tell you which is better. So now, for understanding, we have taken 3 by 3 by, mask or window, filter window, right? Now, what I do is I take this value and put it over this. Please note that this I am trying to put it over this. Okay, on original image. This is my original image. And original image is a 10 by 10 or 100 pixels on which I took one area on which I am matching my window. Okay, so then next thing what you do is you will be doing. I told you, you take all this value, right? Sum it up. You will apply this formula. You multiply each pixel with this value 1, 1. That means if it is 10, this will be multiplied with 1 will be 10 only. This is 15. Multiply 1 will be 15 only. Correct? First you do the multiplication in matrix. Then add what you are doing. Then you are doing sum. Right? You are summing up all the pixel value. Then divide by 9. So for example, I have value 10, 15, 12. 18, 10, 11, 9, correct? So 1, 2, 3, 4, 5, 6, 7. So this is 10. This is, for example, 14. Okay. So this is there's a P1 to P9. Okay. Now, what I do, multiply by 1 means automatically, then add all these things. We get some value. Divided by 9. Then that value will be placed here. P5. What is P5? This is P1. This is P2, P3, P4. This is P5. What is the value? That pixel value is 10. That pixel value 10 will be replaced by the average of these pixels. That's why it's called mean filter. Then what you do? Then next what you do? You shift the window. This window will be shifted. Then this will become P1, P2, P3 like this. Then add the individual pixel value, divide it by 9 and replace this one with that. If this will be replaced new value. Now, if when I do averaging, already I said 8, 11, say for example 15, 10, 12, 9, 10, 11. So what is the odd value? This is a noise. You see that, for example, this is 9. 9 pixels are around 10 only, but 1 pixel are only 15. So this pixel is affected by noise. Now, if I add, what will happen? You are getting average value. That is smoothing. Okay. So by shifting the window, first I place my window here, then replace this value, then shift this window like here, again replace the value, shift the window like this, replace this value. Correct? So by shifting, each pixel will be modified with the average value using this formula of the neighboring pixels. Correct? This is the pixel, these are neighboring pixels. I take all the values, add it, divide by the number of pixels, 9. Here window is 3 by 3 is nothing but 9. So the average value will be filled in this. Then I shift my window. Again average value. Shift my window. Average value. So if I move my window across this one, vertically, horizontally, each pixel. As Kumar, do you understand what I'm trying to say? That means each pixel you have to do here, this is 100 pixels. you have to apply the formula for each and every, then get a new this one. Now you are filtered. Any sudden change is automatically average. That is called filtering. Removing the any sudden change nothing but a noise. In a image, neighboring picture will have same value only, no? If there is a noise only, so you are removing. This is called mean filter. This is how it works. Implemented by a local averaging operation. Each pixel replay by average value of the value neighboring likely neighborhood. Okay, this is mean filter. So, for example, how it works, we want to see. Mean filter output for various masks. Okay, again I told you, the mask or window, filter mask. This is called as filtered mask. Right? The mask size can be 3 by 3, 5 by 5, 7 by 7, or 9 by 9, like that. And bigger. So you are going to take more number of value, average. If I take more number of contrast, if you average a bigger window, the image sharpness will go away because you are trying to average everything. So you should not use bigger. If you want a sharp pictures, then you should use a smaller window size. But it may not remove all the noise effectively. So you have to trade off. Selecting window size when you want to do it, or decide by testing different window size and do. That's what you should do. Right? This is a picture. You can see that this picture has a lot of noise, salt and pepper noise. This filter has been used by 3 by 3 window, 5 by 5, 7 by 7. Right? Then you can see here. This is by 3 by 3. This is by 5 by 7. Result. This is 7 by 7. Correct? So you can see that the size of neighborhood n control the amount of the filtering. Window size. Right? The larger the neighborhood, corresponding larger convolution mask, which will result. This mask also sometimes called a convolution mask. That is called a convolution mask, or a window, or a mask, or convolution is same. Correct? Greater will be filtering. Filtering will be better. You see here, you can notice, see this picture is highly blurred. If you do too much filtering, remove it become blurred image. Right? Sharpness is gone. You can see that here it is better, sharper, but still there's noise is there. This is 3 by 3. This is 5 by 7. 5 by 5. This is 7 by 7. 7 by 7 better filtering, but sharpness is gone. Blurring has happened. So this is here still noise is there. So you have to decide which one is better for. Okay. A trade-off for greater amount noise reduction, larger filter will loss of image detail, which is nothing but edges, sharpness. You cannot see the boundary of the object. Okay. The results of mean filter of various sessions shown here. Already I told you. When the designing linear filter weightage should be chosen so that as a single peak and called as main. Okay. Then symmetry of the vertical and horizontal directions. We'll see what it is. You can, if you want more detail, you have to see that, because we cannot discuss this because we are share. I'm just giving this one. Typical pattern of weighted tree smoothen filter. Correct? This is image. Next type is called what is called a weighted filter, mean filter. No, next type is called weighted mean filter. Okay. What is the difference between this one? The mask weightage is different. So this is called as weighted mask mean filter. Okay. Here you see that here what is the mask value? All are given equal weightage. Instead of that, here you can see that the again this is 3 by 3 only. The corner cells of mask are given 1 by value, side are given 1 by 8, middle is 1 by 4. As a mask and it will be multiplied. What it means is, I take my image is there, because we are going to fit on the same, right? So this is, for example, 10, this is 15, this is 11, 9, 10. For example, 10, 11, 9, 8. Okay, this is original, this one. Now what will, this you will multiply by 1 by 16. This you will multiply by 1 by 16, right? This value will multiply 1 by 16. Then this 15, 14 will be multiplied by 1 by 8. The center one will be multiplied by this. After that, add. Correct? So the weight of the mask is changed. Then multiply this the mask with the image which is covering that area. Then add, then divide by 9. So this is called as weighted mean filter. Weighted mean, you can see that correct? Better than this, sorry. This is 3 by 3. 3 by 3 weighted mean. This is 3 by 3 just mean filter. Okay, so you can see that better noise removal. Weighted mean. Okay. Then next one is called what you call median filter. Okay, next type is called as median filter. Shall we have a break for 10 minutes, then continue?
Yes, sir. That will be better.
Sir, 5 minutes, sir. Bio break we will take and back, sir.
Definitely. We'll give 5 minutes. We'll
Right.
start. Thank you.
Thank you, sir.
So, yesterday I could not see you, not well. What is that? Kumar.
Sir, I was there in the, the video was off, sir.
Sorry, 1 minute. Yeah.
Sir, I was there. I have not missed a single class of you. Every class
No,
I
no,
attended.
because I could not see you because generally you log in first, by
Ji, sir.
450 itself. Generally, you yourself,
Actually, there was a
Yadav,
meeting yesterday. That's why it was.
Yadav, yourself, some 3-4 people generally will come in 10 minutes. I could not see you yesterday. I thought you may be on leave, something. The company may take a leave, something. That's what I was thinking.
No, sir, I was in meeting. That's why I got late.
Okay, fine. No issue. Just I want to know. See, whether it can be a leave or health reason, missing class. That's why I just want to know. Just personal inquiry, nothing more than that.
Sir, thank you for your concern, sir. Thank you so much.
Yeah. Take care. Okay. We'll meet after 5 minutes. Okay.
Ji, sir.
Roshan, we can start. Sir, we can start, sir. We all are come back. Sir, we can start, sir.
Okay, okay. Okay, the next filter is called median filter. Okay, we have another 8 slide only. I will complete in half an hour. So this portion I want to complete. So just maximum half an hour or 15 minutes, 20 minutes. Okay. So the next is called median filter. In median filter, you can see that what it is main problem with local averaging, which is called as a mean filter. It tends to blur the sharpness, discontinuous. That's what we saw, correct? So you can see that it become noise is removed, but picture is not sharp. Edges are not visible, blurring edges are not detected. See, after doing this filtering, you have to detect edges. So if blurred means you cannot detect the object. So you should not do too much filtering also. Sharpness should be maintained. So then means you cannot use mean filter. Okay. Then you, instead of that, you can use next filter. Now, alternative approach is to replace each pixel value with the median value of the grayscale in the neighborhood. We are talking about this is my this one, correct? This is my window again, 3x3 window only. What you do is you are not doing anything. No, you just go and put them order value, correct? So the first value you can see here. The value is already given here. 75, correct? 99, 36, 38, 49, 10, 19, 98, 22. These are the values, pixel values. Now you have put shorted in the ascending order. Then find out what is median value, not mean, median value. Median value is the inbuilt. Out of 9, this is the median value. Now what I do, I will replace this pixel value with that median. What is original value? Actually 49. What you are going to replace? You are going to replace with 38. So, okay. Then what you do? You shift your window like this. Now here, for example, it is 88, correct? 75, sorry, 75, 60. Now again, what you do? You take 99, 49, 98, 36, 10, 22, 88, 75, 60. Now you have to put ascending order, correct? So the lowest value is 10, 22, correct? Then you have 36, then you have 49, correct? 49, next one is 60, then you have 77, sorry, 75, okay? Then you have 88, then 98, 99. What is the mean value? 60. Correct? So now value and replace the 10 will be replaced by 60. This will be replaced by 38. Original value is 49, is replaced this one. So now you have this is called median filter. Okay. The filter is a technique called the median filter. Median filter is very effective in removing salt and pepper and impulse noises. I told you each type of filter is useful for a particular type of noise removal. You have to decide what type of noise you are seeing. Suppose you don't know what type of noise in your autonomous vehicle come, you have to apply different type of filters and see whichever succeeds. Okay. This is called next type of filter, which can remove salt and pepper noise and impulse noise. It may not remove Gaussian noise properly. I told you there are 3 different type of noises, very common noises. The other type of noise also is there. This is a common type of noise. Okay. So the results are shown here. Median filter, correct? So they're taking 3 by 3, 5 by 3, so same, just like a mean filter, we applied this and we are seeing the results. Correct? So the results are shown here. It is better than the mean filter, correct? Median filter, you can see the sharpness is still maintained, whether 3 by 3, 7 by 7, as you do. So this is 3 by 3 result, correct? This is 5 by this one, this is 7 by 7. So lower the filter size, correct? Lower the mask size. 3 by 3 is always give a sharper picture, correct? Sharper picture, but noise is there. Noise is not completely removed. Here you go, noise is removed completely as much as possible, sharpness is gone. So bigger the mask size, correct, or window size, filtering is better, sharpness is gone. Then ideal. So you have to design the 3 by 3 based on depending upon type of the input you are giving. Okay. So next one is called Gaussian filter. This is third type. There are many filters. Sobel filter is there. Sobel, Roberts. These are the filter who invented. We are not going to discuss all those things because there are many types. So basic understanding only. The next very popular Gaussian smoothing. Gaussian smoothing filter is a linear smoothing filter, which chosen according to the shape of the Gaussian function. You know the Gaussian function. Okay. Gaussian smoothing is a very good filter for removing the drawn from normal distribution. Normal distribution also called Gaussian distribution. Correct? If noise is Gaussian distributed or also called a normal distributor, you can use Gaussian smoothing filter. Main thing is you will see that each pixel will be value will be computed using this function. Correct? So you can see that this is kind of x comma y. You can say that in the g into x comma y. That means each pixel will be subjected to this value, right? Multiplied by this value, this one. So that value will be replaced. So the Gaussian noise is removed. In this, sigma determines the width of the Gaussian, correct? This is the width of the Gauss. Correct? So you can have a Gaussian function like this, you can have a Gaussian function like this, you can have a Gaussian. So this is called as width. Correct? This width is the width is called this one. So in this equation, this if you vary the width of the Gaussian function, filtering varies. Correct? Here the filtering quality changes. So this is the third type. Note down. We have discussed 3 types. How they work, you should know, and how it filtering comes. Can I go to the next slide?
Sir, just 1 minute, sir.
Ah, sure, please.
Excuse me, sir.
Yeah,
Am I
yes,
audible?
please. Yes.
So, what will be the typical question that might be asked in this topic?
You saw midsem, no? Similar type only.
Okay. We're just thinking about any question on this topic, so I was thinking if there is any question you might tell.
See, here everything is very basics. No, I am explaining very fundamental because the course is about make it introduction autonomy. Many topics you need to understand. I am teaching basics. Very simple. The image processing we used to teach with our 42 hours separate course. Each topic what I am teaching is a separate course. Filters is the image processing filter alone is separate topic.
Noted, sir. Thank you.
Okay. Then once you have filtered all those things, correct? Then you apply this one, thresholding, right? First thing is capturing image, right? Then if a lot of noise is there, you do the filtering. After filtering, you do histogram analysis. From that, you find the t value. When t value is found, use the t value. Yes, please.
Yes.
Sir, one doubt, sir. In previous slide, sir, we had, sir, sigma value, sir. So, what is that sigma value, sir?
Sigma value decides how the distribute. See, this is a distribution. No, so, smoothing filter is effective for this one. Spread. The Gaussian spread parameter determines the width of the Gauss. How the data is distributed, Gaussian function.
Okay, sir.
That is decided by the sigma.
Okay, sir. So that will be decided based on the image, or means how it will be, sir?
And that is based on the how the data is distributed.
Okay, that will vary image to image, sir.
Yeah. Then you have to you apply different this filtering works.
Okay, okay, sir.
In this
Okay, sir.
equation, change the sigma value for different value and
Yes, sir.
see the result of the image. Correct? So you are saying the noise removal and smoothing both changes if you vary the sigma value.
Okay, sir. So, mean to say, means, sir, like suppose in some process or something, like they will alter the value, means
Of
hit
the
and
sigma
maybe
value they change and see how the
Yeah.
filter effectiveness is.
Yes, yes, sir. Understood, sir. Understood. Thank you, sir.
Thank you, kind of you. Thank you.
Width where the middle of the portion or bottom of the plane, roughly where we are measuring, sir?
I will tell you next class. I will clarify you.
Okay, sir.
Thank you. Thanks for your time.
Thank you, sir.
Okay. Next is once this is thresholding is done. First thing is capture the image. If the color image, what you do? Convert into grayscale image. If color is not needed. After that, if lot of noise is there, you do the anyone of the filtering method. Once filtering done, then you do thresholding. Before thresholding, you apply the histogram and find the three type of histogram methods are the threshold direction methods. Histogram method, modify histogram, all those things. Using that, you do then do the threshold and do the thresholding. Right? They call segmentation. Then what we will get is what you call edges. You finally from the image you will get edges. Original picture is converted to a frame with the edges. Once the edges are there, edges can be edge is no definition. Edge is nothing but edge is in an image is a significant local change in image intensity. Correct? For example, I have 2 pixels. Correct? For example, 2 pixels. This is x comma y, x1 y1. This is x2 y2. This value is, for example, 100 intensity value. This value is 150. Correct? Between these two, there's sudden change in the intensity value. Then I call this as edge. Pixel, that is called as a edge. That represents a boundary of an object. Probably. It's not compulsory. It can be noise also. Generally, if sudden change in the intensity level changes, that point is called as edge. That edge may represent boundary of an object. Right? For example, I have a frame like this. Right? These are my pixels. Dots represent pixels. Now I have a small circular object as something like this. Okay. Now what will be the value of this one? So all these pixels will have 255. The background is nothing but white. What about this pixel? These pixels alone will have red means, for example, 120. all this pixel will have 120. Now, this is called a edge because neighboring pixel has 255, this has 120, correct? So this is called edge, that point where changes. So please see that wherever the sudden change, it represents the boundary of the square object, correct? So that's what we are talking. Usually, the discontinuity is either image intensity or the first derivative. Suppose if the change in the intent is not abrupt, correct? Then it's still, that means if you have filtered too much, correct? Smoothened too much, what will happen? The intensity level already average, there's not sudden change, graduation. Then what you do? You do a differentiation. D by dt of that intensity value, if you do to this one, then you will get value will be your edge. Discontinuous in the image can be step discontinuity, correct? That means this is one pixel, this is other pixel. This value is 100, this value is 150. So suddenly between these two pixels. So this is called step change or step edge. Next one is ramp edge, correct? So I have one pixel here, another pixel here, another pixel here. This pixel is 100, this is 150, this is 200. So you see that my edge is changing. Correct? For like 100, 120 for you understand this one, maybe 150. Correct? So gradual change is there. This is called a ramp type of edge. Correct? Then line type edge means there is one pixel, another pixel, this pixel. These are 100, 100. This is 150. Correct? Middle pixel. This is called as line discontinuity. It's a sudden change. The one pixel high value, before and after other pixel, the neighboring pixel have lower value. This is called as this one. Third one is roof type picture. So the intensity value may change like this. Correct? This is called roof. Correct? Type this. These are different type of edges you can see in your picture after doing segmentation. Correct? Already again repeating. First you take a picture. If it is a color picture, you don't want color information, you do color to grayscale conversion. After that, what do? You apply, remove noise. Once noise is removed, then you apply to histograph, find the threshold value, use the threshold value to do the segmentation, correct? Then you will get edges. Once edges are detected, that's what edge detection. Now we are talking about edge detection. Line discontinuity, okay? However, step, correct, or roof type. Sorry, ramp or generally, correct? Special case it can be there. Because of smoothing, why it happens? If you do filtering, automatically the step under this both will go away. Because you are averaging, correct? Neighboring picture, you average, automatically will get a ramp only, ramp or roof only. These two, but you want to filtering, step type and also line type edges. But it will have a lot of noises. So when you do, that's what we are talking. Step and larger edges become roof edges, where the intensity changes not instantly but finitely, slowly over a distance. Okay. Edges, an edge point is a point in an image with a coordinated, nothing but a pixel, correct? This is nothing but a pixel. Okay, at the location of significant local intensity change. Then you will hear when you talk about the image processing, you'll talk edge points, and edge fragments. Okay, so edge point means only one point, correct? Edge fragment means multiple points having closely nearby. It can be like this, it can be this, correct? These points, it can be like this, correct? So this is called edge fragments. Okay, it can be individual points or many points close to it. Can be any direction, nearby points having same intensity level. Okay, so edge fragment I come as a coordinated edge, and edge orientation. It will have a orientation also, which is called a gradient angle. We'll see that next. So steps, how will you do the edge detection? See, once you are done thresholding, to identify the first thing what you have to do is you have to do edge detection. You have to find out where the edges are. See, you have say 1900 by 1000, 1900 by 1200 pixels. Can be a high resolution camera. So millions of pixels are there, right? Millions of pixels are there in the frame itself. Now you need to find out the object. To find out object means you need to find edges. Edges represent the border or the shape of the object, right? Boundary of the object. That's why you have to first find the edges. Then you connect the edges. First identify edges, then connect the edges. Then you'll get the connecting edges will give the outline of the picture or boundary of the object, any object. So filtering already we know, enhancement already know. Then we need to do edge detection. Correct? Edge detection is points with strong edge contents. Maybe many points in the edge may have non-zero value for the gradient, and not all the points of the edges can be particular applications. Many times the edge may not represent the boundary of an object, need not be. That's what we are trying to say. Okay. Hence, there need a method to determine which points are the edge points. In the given your frame, you need to know a method how to find edge points. Mostly thresholding technique is used. Here only we are using thresholding. Right? By thresholding, you'll be able to detect the edge boundary of an object. The very popular method to find the edge is the gradient method. Simplest method and is called gradient method. Detection is essential of detecting significant local change in the image intensity. In one dimension, a step is associated local peak of the first derivative. Okay, between two pixels, if you find the derivative, change in intensity level represents an edge that we call gradient. There's a change in pixel that is called, if we take a derivative, you say by the gradient. So gradient is the two-dimensional equivalent of the first derivative, and it defined as a vector using this equation. Right? So now gradient is the vector g f of xy points in the direction of the maximum rate of increasing function f of x comma y. Right? This is input function. Now you are trying to find a gradient g. How will you find out? By taking first derivative. Right? By taking first derivative, you are finding it. One is in x comma x direction and also y direction. Which direction the change is happening? In the x direction or y direction? The vector point this one. The magnitude of gradient is given by this function. Correct? So gx square plus gy square root if we take, that gives the magnitude of gradient, which can be found using this also. And the direction of the alpha xy can be found using this tan inverse of gy by gx. Which direction this is happening? Shall I go to the next slide?
Yes, sir. Yes, sir.
Okay. So results of different type of edge detection. There are different methods are available. Correct. So this comparison edge detection, original image is this. Okay. I told you. Next, what you do? Filtered. This noise should be removed. It may be here we taken directly grayscale image. If the color means you do the color this one. After that, the C represent simple gradient method. Correct? This represent. So our whole idea is we have to detect this spanner. Spanner is there in the image. So you are able to, this is the edges, and by connecting edges, you are getting, this is the edge, and by connecting that, you are able to identify the spanner. And what they use threshold level of 32. That means what you have to do. One step I have not shown here. What is that you have to do now? See, original image, then you filtered. This is filtered image. Then you set the threshold segmentation. Identifying, correct? So what is this missing here? You take a histogram and identify the T value. Then apply it to the image. Then only you will be able to find. Okay. So they show different. First is T equal to 32 threshold level. Then using gradient method, right? Gradient to discern, they said threshold equal to 64. Again, see, I told you there are many different type of these ones are there, filtering and thresholding techniques. See, Robert class operator, Sobel operator, Prewitt. Because we are not discuss all this thing. Don't worry about it. If you want detail, go to this book and read it. Image processing is separate book, around I think around 300-400 pages, big book. Correct? It is a separate course. Just you have to understand how it works. The whole idea is that. Just for information, this slide is just information only. Okay. Now, once edges are detected, correct? So, edge represent border, this one, you have to identify the object. To identify object, you also what you call contouring. Contour or contouring, connecting the edges. So, that means I say that there are edges like this. So, I can connect by like this one. So, these are the edges. If I connect, I get a shape. Connecting the edges is called contouring or finding the object. By connecting edges, then see edges represent only one. If you want to know the shape, you have to connect the edges. If you connect the edges, you will get the object shape or border of this one. Contour can be open contour or closed contour. Closed contour corresponds to region boundaries, and the pixel in the region may be found by filtering algorithms, filling algorithms. Correct. So what is the exact this one? By connect the edges, then fill it. Then I can find out what object is. Right. That's what I am saying. Filling by algorithm, you may find the region. Open contour may be a part of the region boundary. Right. Then gaps can occur in the region boundary because contrast between regions. Suppose if poor contrast is there, correct? I wanted to, for example, correct? So now here there's no contrast. That means poor contrast is there. What will happen? You will get something like this. Then you may get a discontinued like this. Correct? This area are not able to, because edges are not visible. Correct? If contrast is not good, when you apply thresholding, you may not get the edge points. Then you are not able to. That's what you're thinking. Some region may not be missing. Then we'll say that this is an open con. This one, I'm able to identify, but it's not closed. It's an open con. Correct? This is a boundary. Boundary is not closed. Another thing is edge detection threshold may be set too high, or the contrast along some portion of boundary is so weak related to other image, so the single threshold value is sufficient to detect the edges and also found the boundary. Correct? When you do this, that's why it's image processing many times is a trial and error method. You have to set different filtering, whether 3x3 filter, 5x5 or 7, this one, or mean filter or median filter, or this one. correct? Like that, what is the T value you will set? What are the, whether you use histogram method, what method you have to use? There are many, correct? So everything you have to do to before finalizing what type of algorithm will be used for detecting the objects. Okay, so curves and segments. Now, when we wanted to find the connecting edges, correct, or contouring, edge detection, these are the important definition. One is called edge is a list of ordered set of edge points in your fragments. Okay. The second definition, a contour is a edge list or the curve that is used to represent edge list. These are definitions. Okay. Standard definition. Why this is out? That is how definition you cannot change. You have to understand. Third definition, boundary is the closed contour that surrounds a region. Okay. Now, nothing but contour is nothing but going to show the edge of the or boundary of an object, right? So, how will you connect the edges so that the object shape can be, it can be connected by line segments or circular arcs or conic sections or cubic splines. Different of lines will be used for connecting the edges, correct? My edges, if my edges are this one, I use a straight line, correct? If my edges are like this, I try to use circular arc, correct? Instead of that, my edges are like this, correct? I cannot use straight line, I cannot use circular this one, I use a spline. The dots represent edge points, correct? Edges will connect. So this represents, so if I have an object, correct? I have an object something like this. Right? This is my object in the frame. So these are my edges. Dots represent edges. If I want to do contouring, what I do, I will try to use connect this. I can connect this with a straight line equation, correct? This is straight line, this is straight line, this is an arc, circular, this one. This is a spline, correct? So now if I connect all these things, I'm getting an object. This is my shape of the object. This is how you detect the object. By connecting the edges, you detect the boundary or contour of the object, so you can detect the object. Object detection is done. That's how the objects are detected. So simplest method is I'm not going to talk about how to fit spline, circular, curve fitting. This is nothing but a curve fitting, right? Simplest thing is what is the straight line fitting, correct? The most popular method is called Huff transform. I think time up. I will stop here. Tomorrow we will continue just another two more slides, and we'll start next topic tomorrow. Okay.
Okay, sir. Tomorrow 2 hours, now, so same time.
Yeah, same 2 or 5 to 7. I want
Okay.
to top a new topic, that is the CAN bus
Right, sir. Right, sir.
communication system. I want to start.
Right, sir. Right, sir.
So yeah, just 2 more slides are coming. After I will start about communication buses. That
Sure,
will
sir.
be for 2 classes. After that, we will talk wireless communication. Then last one is path planning. So another 8 classes I will complete. 8 to 9 classes I will complete.
Okay, sir.
Okay. See you tomorrow. Thank you.
Thank you, sir. Bye.
Take care. Give your
Thank you,
attendance
sir.
as a chat message. Don't forget that.
Sure, sir.
Okay.
Thank you.
Thank you. Take care.
Thank you, sir.